What it do? It's Osmo Spam back at it again, man. It's a new year, man. We made it to the new year, man. So you know what? It's a new grind, and the grind starts today. You feel me? I'm reacting to NASA warns of coming massive solar storm to Earth. It's a Destiny video, you feel me? So you know me, about to hop right into it. Let's do it. Boom.
Recently, there was an unusual solar storm on the Sun, which formed a giant fire canyon. NASA's Solar Dynamics Observatory showed a vivid animation of this huge ejection of charged plasma. The solar wind reached Earth in April 2022, and on August the 9th, after a solar flare, charged particles bombarded our planet again. At 600 kilometers per second, they collided into Earth's magnetosphere, causing auroras. The northern lights were visible in the US states from Maine to New York. But scientists say this time we were just lucky. If a more powerful solar storm hit the Earth instead of a brilliant celestial show, it could have ended in a disaster. Solar storms have already shown their destructive power at least twice in the past. Now, our sun is once again nearing its maximum activity, and the likelihood of another powerful burst of plasma is increasing. How did these solar flares affect our planet in the past? And does the peak of our star's activity in 2023 threaten the Earth's destruction?
Yo, his intro was dope. I need to get me an intro like that, man, for real.
Solar wind is created when a stream of high-energy particles can no longer be held back by the sun's gravity. Scientists think these solar winds blast from large dark spots on the star called coronal holes. The sun is a huge distance from Earth, and yet coronal mass ejections can reach us in between 2 to 6 days. But the highest energy particles can overcome the same distance in just 2 minutes. Most of them are redirected to the poles by the planet's magnetic field, and only a small number of particles penetrate the atmosphere, emitting rays as they collide with gas molecules, causing the atoms to give off light. But sometimes the sun starts having extremely powerful flares with the energy of about 10 to the 25 joules. That's roughly equal to millions of 100 megaton hydrogen bombs. During such a solar storm, plasma rushes through space twice as fast as usual. It bombards the magnetic field of planet Earth with such force that charged particles either pierce or significantly deform it. The result is the formations of geomagnetic storms, the strongest of which can lead to many disasters. On September 2nd, 1859, British astronomer Richard Carrington observed a giant solar flare. 18 hours later, one of the strongest geomagnetic storms we know of struck Earth. On that day, telegraphs in all of Europe and North America stopped working, and many telegraph poles were burned. People could see the northern lights almost all over the planet. Mankind recovered from the accident relatively quickly, but our civilization wasn't as dependent on electricity as it is now. When another major solar storm struck Earth in March 1989, the entire Canadian province of Quebec plunged into darkness, leaving millions of people without electricity for 12 hours. The solar outburst that caused this wasn't that powerful. If the next explosion on the sun reaches the power of the Carrington event, the most intense geomagnetic storm in recorded history.
Just wanted to start a business when something surprising happens.
Today I'm going to teach you.
Nah, but that's crazy though. Can you imagine like chilling somewhere and then all of a sudden you see the northern lights in the sky? That shit would be spooky. I would be scared, low-key. I'm like, damn, it's the end of the world.
It would be a catastrophe. In the past, scientists thought that the solar storms of this magnitude don't occur more often than once a century. But then, scientists from the University of Warwick and the British Antarctic Survey analyzed the patterns of solar flares. They discovered that powerful magnetic storms are much more frequent than previously thought. Solar activity has approximately an 11-year cycle. At its peak, the sun develops a particularly violent activity, and charged particles are directed towards the Earth one after another. Researchers have analyzed the complete catalog of changes of a magnetic field of the Earth. The results confirmed that the most significant bursts of geomagnetic activity coincide with the most powerful explosions on the sun. The team of scientists identified 2 types of the most dangerous events for the Earth: strong magnetic superstorms and the strongest destructive megastorms. The former occur on average every 3 years. They affect the health of weather-dependent people, often causing headaches, blood pressure spikes, exacerbation of chronic diseases. But they don't...
Wait, how is the sun gonna cause you to have blood pressure spikes? That's crazy. That's crazy, man. Some things are out of your control, huh?
...to significant technical failures. Mega-strong storms are much rarer. Over 150 years, researchers have counted only 6 such events. So, solar storms range on our planet about every 25 years. And over the past 2 decades, there have been no megastorms. Scientists expect the next one to happen in the near future. A huge, potentially dangerous outburst occurred on the Sun in 2012, but the solar wind at that time blew the other way and hardly touched our planet. During the next giant solar flare, we may be less fortunate. The exact consequences in such a scenario cannot yet be predicted. What we know for sure is that colorful auroras will be visible all over the planet. It's also possible that among them, there'll be a special kind of a northern...
Yo, if that's true, you know people gonna take the craziest YouTube videos and TikTok videos showing the sky. Like, people gonna have their phones out, bro. You can see the aurora borealis everywhere on the planet. That people gonna be just super happy, even though it might be the end of the world. That's crazy.
Light called a strong thermal emission velocity enhancement, or STEVE, appearing as purple and less often white glowing ribbons during the August 2022 geomagnetic storm. These auroras were observed even in southern Pennsylvania. Scientists don't know the exact nature of this optical phenomenon, but it's usually seen during solar storms. Researchers are confident that STEVE isn't just about the glowing show in the sky. It could be accompanied by the megastorm that will cause major disruptions to electronic and aviation equipment, communications, power grid disruptions, and issues with satellites. It could even reach the depths of the ocean, destroying underwater online communications cables. This would lead to a worldwide internet apocalypse that would last several months or more.
Yo, I'm sorry to pause, but can you imagine everybody just loses their phone? Like, people will lose their absolute mind. You know what I'm saying? You can't get on TikTok no more. You can't get on YouTube no more. You can't play the Xbox or PS5 no more. People are going to lose their shit. Like, altogether.
According to some estimates, the damage could well amount to billions or even trillions of dollars. If solar winds of this power hit our planet in 2012, some countries probably wouldn't have fully recovered up to this date. Still, the absence of lights, computers and televisions seems like a trifle compared to a majority of other possible effects, like droughts, floods, earthquakes and tsunamis. These natural disasters are often attributed to solar storms. Observations show the maximum frequency of earthquakes is observed in periods of high and fluctuating solar activity. It could have been one of the reasons for a magnitude 9.1 earthquake that happened in 2004. It also caused a huge tsunami in Indonesia. India, Thailand, Bangladesh, the Maldives Islands, Sri Lanka and Somalia also suffered from this natural disaster. Over 283,000 people perished, another 14,000 people are missing, and more than 1 million are homeless. To mitigate the disastrous consequences of solar storms, scientists need to have a warning system. Several spacecraft, including the Solar and Heliospheric Observatory and the Solar Dynamics Observatory, are studying the Sun. Their data will help alert us about extreme events on the star in time. Now, as the Sun nears its 11-year peak of activity, this is especially important. And only once the stormy activity of the Sun goes down in 2024 can we breathe a sigh of relief. Or can we? Recently, scientists found that a powerful geomagnetic storm is able to ignore the 11-year solar activity cycle and suddenly strike the Earth during the Sun's calm period. Scientists have again found a similar example in our past. A new study of ancient ice samples under Greenland and Antarctica has shown that 9,200 years ago, a solar storm of unprecedented strength hit our planet. So destructive solar storms can happen when we least expect them. To avoid being caught off guard, many governments have declared space weather forecasts to be a priority in the development of science. High hopes are pinned on NASA's Parker Solar Probe. The probe now travels closer to the Sun than any spacecraft did before. This means it can spot coronal emissions faster than any other spacecraft. Data from the Parker Solar Probe will help scientists more accurately track the region of a storm's formation on the Sun and possibly determine its direction. NASA and the European Space Agency also launched the Solar Orbiter probe in 2020. It's now traveling in an elliptical orbit with the closest point of 42 million kilometers from the Sun's surface. The probe has already sent incredible images of the star back to Earth. Some of them show many small bright spots and strange dark objects, which are moving and vibrating. These are miniature plasma eruptions that scientists call campfires. Such phenomena probably raise the temperature of the star's corona and cause solar winds. Meanwhile, other researchers are looking for ways to protect Earth from space. Recently, Japanese inventors from the National Institute for Fusion Science developed an artificial geomagnetic field project. According to geophysicists, the planet's own field has become about 10% thinner over the past 150 years. One day, it may not be able to withstand the outbursts of highly accelerated charged solar particles. Scientists suggest launching 12 superconducting rings around the Earth to protect it. Such a structure is thought to be able to enhance the geomagnetic field of the planet, but it can only compensate for the 10.
Yo, scientists be coming up with the craziest ideas. Like it's their job to do that, I guess. But damn, you want to build wires around the globe, bro? Ain't nobody got time for that, bro. Like, come on. Like let's be serious. Like, if I was a scientist, I'd be coming up with bullshit ideas all day, getting paid thousands, man, for real.
Percent that it's lost. But maybe we don't need to build any protective structures around the Earth, as they're already there. NASA's space probes discovered a kind of artificial energy barrier around the planet. And it was formed by humans due to the interaction of very low frequency radio waves with cosmic particles. The human-made barrier was found using Van Allen probes, which are designed to study electrons and ions in space around the Earth. Normally very low frequency signals from radio telescopes are transmitted from Earth and used to communicate with submarines deep in the ocean. According to NASA scientists, these signals formed what looks like a huge bubble of energy enveloping the Earth. Its outer layer extends almost exactly to the inner edge of the Van Allen radiation belts. These belts collect charged solar wind particles that later attack the planet's magnetosphere. Researchers say that in the absence of bubbles, the radiation belt boundary would be much closer to Earth than it is now. In the 1960s, when low-frequency communications were less common, the inner boundary of the Van Allen radiation belt was at a much smaller distance from the planet's surface. Do you think this type of shield can protect us from the consequences of the most frightening solar storms? Or should we consider other, more reliable ways to defend ourselves? Tell us in the comments, and thanks.
Bro, this guy, is he trying to say, like, we can't defend ourselves from the sun? The sun, bro. The sun decided to take us out, it's over. Like, there's nothing we can do to protect ourselves from the sun. The sun is like a nuclear bomb that's consistently exploding. Like, come on. But scientists, like I said, scientists come up with all kinds of crazy ideas for all kinds of crazy issues. But yeah, I lost what I was saying. But hey, if you like the content, don't forget to leave a comment, subscribe, and leave a like. You feel me? This is a new year, man. New me. I'm going hard with the reactions, you feel me? I was kind of wanting to see, like, if people like scientific kind of stuff, you know? Let me know. You know what I'm saying? What do you want to see me react to? Really. So, I'm out of here. Catch you guys on the next one.